Good morning, good afternoon, good evening, wherever you are. Welcome to this presentation on the call of technology, compression understanding of industrial data. The structure will be about a few slides about MPI. Then there will be the presentation of the technical call, and that will be for Guido to perform. And finally, some logistic and other details on the call and the submission of responses. So let me start about MPI. Well, who is MPI? MPI is Moving Picture Audio and Data Coding by Artificial Intelligence. We are an international unaffiliated nonprofit association based in Geneva. We have a mission to develop technical specification for coding of any type of data, especially using AI and the technology that facilitate integrated of data coding and decoding components in ICT systems. But we do that trying to bridge the gap between the technical specification and their practical use by means of the intellectual property right guidelines. And we have an application for this call as well. We do our work based on the open international collaboration of interested parties, supporting the MPI mission and the means to accomplish the mission. So one major concern that we have is that AI is a great technology, but we are keen to know what's happening inside to the extent possible. And we do that in the following way. Let's assume that we have a subsystem, we call it the AI module, that receives data in and produces data out and possibly accesses some other data. So we have many of these. We integrate them in the workflow. We connect all the pieces. And in this way, we think that we are able to understand better the flow followed by the system to produce a certain output. So this has been formalized in a standard. This is one of the first standards that we produced that is called AI Framework. As you see, we have connected AI modules. Then we have a controller. We have API to access several services. The one that you see, the blue ones, the communication service, encryption service, and attestation service, are all enabled by the by a security layer. So then let me give some words about the fact that we wanted the standard to be actually accessible, to be actually usable in a timely fashion. And this is our method. Before we initiate a standard, the active principal members developed and adopt the framework license related to the standard. It's called a license, but actually it is not a license because it does not have the main element, which are how much it costs, what is the percentage, at what date something happens, and so on. So that is not said, but we say something that is important, because we say that the eventual license, the license that will be eventually produced, will be issued not after the products are on the market. So you know that you will be able to I mean, you will not be disadvantaged vis-a-vis other competitors, but at a price comparable with similar standard technology. Then what is similar and what is comparable? Of course, there is a degree of space, but this is the core. Then during the development, any member, because only members can participate in the development, making a contribution declares it will make its license available according to the framework license. And after the development, MPI facilitates the identification by members, because the decision is by members, of a preferred patent pool administrator. So these are the main elements. Then we have another important point, that we have a rigorous standard development process. We have an idea, we develop use cases, we develop functional requirements, and when this is done, we the principal members, as I've just said, develop the commercial requirement, also known as framework license. Based on that, we can issue a call for technologies. We receive technologies, which is exactly what we are trying to do today, to invite you to propose technology that are relevant for this standard. Then we develop the standard. When the standard has reached a sufficient maturity, but not the final one, we make a publication asking for community comment. Based on these, we produce the technical specification, the reference software, conformance testing, and performance assessment. So this is our rather rigorous development process of our standard. So what we have done based on this? Well, quite a few things, because we have 14 standards that we have produced. And in particular, you see marked highlighted in red, comprehensive understanding of financial data, which we developed at the end of actually in September 2021. So this again was one of the first standard that we produced. But we have standards in several other areas that I mean, they are not directly connected to comprehensive understanding on financial data, save for the fact that it is based on the AI framework, as I have said, but also, I mean, we have an underlying layer of AI technologies that are shared by all these standards. Of course, this is not the end of our life, because we have plans for new and extended standards. And again, what is highlighted in red is version 2.0 of Empire COI, comprehensive understanding of financial data. And then we have, as you see, quite a few more standards that are in the process. At this point, I leave the floor to Guido. Please, Guido.
Thank you, Leonardo. Thank you, everybody, for being here. Can you hear me? Yeah? Okay.
Yes.
Okay. So let's start with a little bit of history, let's say. So from where we are starting with, and why we need to create a new version of the standard. So in the first version, we have the following situation. We have to define a prediction horizon. We start from data about governance and financial, plus a company assessed risk data. Then we compute some standard descriptors from the governance and financial data, and we convert the risk in a risk matrix. Why that? Because in the first version, we were supposing that we had an AI module just for the governance, the financial data, while for the other ones, we needed to, in practice, to use the existing ones, governance, financial data, perturb them according to the risk matrix, and then obtain a discontinuity probability. Next slide, please. Okay, this is the depiction of the version 1.1 of CUI CPP. This is exactly what I presented before. As you can see, the risk matrix generation, so the risks which are not financial and governance, are put inside this risk matrix generation module. It creates the matrix of perturbations, and using that, we perturb the financial and the governance data in order to obtain the effect of those risks over the financial and the governance. In the next version of the CUI CPP, we want to go further. So we want also to incorporate the information and the AI related to some verticals of other risks types. Okay, those are the data that we need. So governance description, financial descriptors, and the risk matrix. In particular, we see that in the risk matrix, we have the occurrence of each risk, the business impact, and the gravity value, plus the risk retention. So the portion of the risk that the company decides to retain. Next slide, please. Now, what we do in the next version? First, we want to be able to consider more and better data. So a more precise identification of some risks, in particular cyber, digitalization, climate, and business. The possibility to incorporate different IAMs for the different risks. Why that? Because you might have different AI according to which data you have access, or to which regulations you have to be compliant. For instance, there is a big difference in managing data in US and in Europe. So it might be easily that in one continent you can use certain AI, in another one, the same AI cannot be used due to regulations and not to problems on data. That obliged us to define what is a risk in a quite general way. So a risk is given by a name, a type. The type is given according to a taxonomy, which is standard over the family of risk. So why we need both the name and the risk type? For instance, if you consider climate change risks, you can have different types of risks according to which effect you are considering. I don't know, flooding, for instance, or the quantity of rain. The two things are correlated but are not the same, and the AI will be not the same. The target regulation, so what according to which regulation this AI is compliant. For instance, if we consider the AI Act, we know that to be compliant, we must follow some rules which are different from the US ones. So an AI can be, as I said before, compliant to a certain regulation, not to another one. Or in other cases, we might have some specific regulations. For instance, if you are a company which is working in a certain field, in a certain sector. So in that case, you must use a certain AI and not another one. And then we need a vector of inputs. So can be an image, a text, a category, and whatever, and the value, which depends on the type. This is a general schema that can be later on, can be later on extended to different types of inputs. In such a way, we can be flexible according to the different AI models that we have. Again, for instance, because some inputs can be used freely in the US, but not, for instance, in the EU due to the GDPR, for instance. So in such a way, we can be flexible, more flexible to those kind of changes without having to rewrite the entire a new version of the standard. Now, can we do more? Oops, wait, okay. So with this additional information, it is possible to train a neural network or several neural networks. We can provide risk data to better predict the governance and the financial and the financial risks. That means that all the index and probability outputs of this UI becomes descriptors, as we will see, because we enhance also the output of the CUI CPP. So descriptors are data structure. They include index or probability as values, but also information about the influence of the input elements. This is very important because it's becoming more and more relevant to obtain explainable AI. It is not just a matter to say saying, I don't know, you have a high risk of a on the cyber side, but I want also to know why I have those kind of risk, because it might be easily that two companies, they have the same risk index, or there is the same probability to be attacked, but the reasons are different. And sometimes the reasons are more important than the value itself, because they guide later on the company or the professionals in order to secure the company itself. Great. So this is the new structure of the CUI CPP. We still have governance financial data. We have the horizon, the prediction horizon. We have the risk data, and the risk, and still the risk assessment. Why that? Because we might have that for some families of risk we have AI, but for other ones we don't have. So we still use the old perturbation method. We can use the old perturbation method. Can be, for instance, that we have for a certain risk just one AI, which is compatible with the regulations on EU, but not in the US. In that case, if is a US company who is asking the prediction, we can still use the old risk assessment system. Or if for a certain family, we still don't have any kind of AI, for instance. And as an output, we have organization descriptors, default descriptors, discontinuity, and the discontinuity probability, which are the old probabilities given by the risk matrix generation. Let's say the AI work now is done in that assessment and prediction macro module, where there is the old organization and default prediction modules and the discontinuity prediction. The discontinuity prediction contains different modules according to the different risks which are managed by the specific implementation of CUI. So, in order to feed that new standard, we need, some of the old data and some new data. So the governance data, we have data about the officers in the last 5 years, and including information about the fact that the officers have roles in other legal entities. This is an extension of the old CUI CPP. Financial data are just eventually can be extended from the old one, even if the old version was already compliant to, let's say, a common structure, which is the common template, which is in use in all around the world, because with having that every nation has some peculiarities, thanks to God there is a sort of macro vision of the financial data which is shared in all around the world. So this is the minimum that you must have to be compliant and to be, let's say, have readable data which are compatible in US and in Europe. The risk assessment, so there is a risk taxonomy which, plus eventually the extensions to the old CUI CPP that were already present in the old version, and the new part, there is the vertical risk data that I was discussing before, including the vector of inputs and the output, which are now, as we said, the descriptors. So we have all the components of explainability of the results in order to give to the user a clue on how to act in order to reduce those risks. Those are the next steps. So we issued the call for technology in December the 18th. Today we are presenting the call for technology. The next steps are the notification of intention to submit a proposal by the 18th of January. Then, I mean, there is a deadline for the response submission by February the 11th. And then we start to evaluate everything starting from the 19th of February. So for the MPIA 53 meeting.
So about the call for and the responses to the call, there is some logistic, practical details, and also some other details for which it's important that we give an alert to you. So this is the summary of timeline. The publication was made on the 18th of December, and today we are presenting it. In 10 days, you will be requested to notify of your intention to submit a proposal. I mean, this is not a mandatory, but it's highly recommended. But what is an absolute deadline is the 11th of February, because that will be the submission deadline. And then immediately after the next General Assembly, MPI 53, we will start the evaluation of the responses. So how will the specification be developed? I mean, we have already developed 14 of them, and actually in more versions, so we are quite experienced by now. But in any case, this is the summary. We will develop the standard using technology that satisfy the following mandatory requirement, that satisfy the version 2.0 use cases and functional requirement, and are proposed that responded to accept the MPI COI framework license. But this is not the only time proposals can be made, because the technologies can be integrated by additional contribution presented subsequently. But of course, if someone has presented the technologies in response to the call, and you come with another technology that does more or less the same thing, the first one has the right to say, no, you had an opportunity to respond before. So it's really an integration, a clarification, a small improvement to an existing technology, what we intended to do. And of course, if you make such a contribution, you will have to state acceptance of the framework license, on which I will say more in a second. You are not required to be an MPI member to respond to this call for technologies. But if you have a submission or a part of submission that is accepted for inclusion in the standard, you should join MPI or lose the opportunity to have your submission accepted, included in the standard. We will select the most suitable technology based on their technical merits, but you should remember that the call does not obligate MPI to select the particular technologies. And in any case, we are not obliged to accept any of the proposed technologies if we found that what has been proposed is inadequate for the standard that we intend to develop. With that, MPI looks forward to working with you on this exciting MPI project. please join MPAI. You will share the fun and build the future. And here you have a link for the online material related to the call for technologies. Thank you for your participation.